Hello. All right. So we are moving on to section 2.3, which is great. I think this is kind of the beginning of where students start to feel a lot more comfortable with the level of difficulty. There's not as much notation. The limit process has gone away, you guys. We're just going to straight up take derivatives. Okay. And there's lots of different rules on how to take derivatives. So I think a lot of you will probably get into a comfort zone here over this next chapter. And just apply rules and do algebra stuff that it's not too cumbersome. Okay, so we're going to talk about at the very beginning the derivative of a constant. So let's pause for a second and think about what the line y equals 4 looks like. So on a coordinate axis, you've got the line y equals 4, which is 1, 2, 3. We'll just call that 4 right there. Okay, so this is our line y equals 4. That is our function. Okay, call it f of x, y, f of x, same stuff. Okay, it's definitely a function. What is the derivative? Well, you guys have to remember the derivative, I'm going to say this over and over again, tells me the slope of a tangent line at any point. Okay, so let's go to 1. What's the slope of a tangent line? Well, the tangent line would be a flat line right there. The slope would be 0. What about right here at 3? The slope is 0. And so when you have a constant, the derivative will always be 0 because everywhere on that flat line, the slope is 0. Okay, another way to think about this, call your function 4, right? We haven't learned the power rule technically yet, but I did teach it to you in the last section. Think about 4 is the same as 4x to the power of 0 because that would just be 1, right? And if you use your power rule, you would do 0 times 4, x to 1 smaller, okay, which would be 0 over x, which is 0. This is a really complicated way to think about it. I think it's much easier to think about graphically or to straight up memorize, okay, which is what most students do. The derivative of a constant is 0. And so if f of x equals 5, f prime of x is equal to 0. If it's root 3, f prime is 0. Right? F prime is 0. And don't forget that pi is definitely a number, right? It's an irrational number, but it's not a variable, right? Sing your ABCs, pi is not in there. Okay, the derivative of pi is 0. Okay, then we get to our general power rule, which we mentioned in the last section. And it just makes your life so much easier. Okay, if you're given a function that f of x is x cubed, think about what you would have to do with the limit process, the formal definition of the derivative, which would be the limit as h goes to 0 of f of x plus h minus f of x all over h. And it's a disaster. The power rule simply says take your power and put it down in front. If there's already something there, you multiply, and then raise your variable to 1 smaller. And so f prime here would simply be, bring down the 3, x to 1 smaller is 3x squared. F prime of x here, 3 comes down and joins the 2, so it's a multiplication. 3 times 2, which is 6, x to 1 smaller. F prime of x here. This is a variable of pi. And so if you bring pi down, it's right there. And then follow your rules. That'd be x to the pi minus 1. Right? And this is totally okay. Just leave it like that. And then over here, f prime, this is x to the e, same thing. It's e times x to the e minus 1. So you're just following your rules. I know you guys don't like that, but there's nothing wrong with it. Why do I leave it like that? Well, pi is irrational, right? It goes on forever. And so if you try to make this a decimal and you say it's like 2.14, it's definitely an estimate now, okay? Because you're truncating that decimal that does never end. So it's better to leave things in terms of pi. It's more exact. Okay, okay, let's keep practicing here. F prime of x, you bring down your e times 2 would be 2e. X to the e minus 1, 1 smaller. Okay, here f prime, 15, x to 1 smaller. Okay, here f prime, 2 times negative 1/2 would be negative 1, x to 1 smaller. Okay, so all of that simplifies to that. F prime here, your coefficient is pi to the 4th, and so if I bring down the 3, I just have 3 pi to the 4th, x to 1 smaller. Okay, so even though some of those look weird, you just have to go through the process and follow the rules. Okay, so then there's a sum and difference rule. To me, you guys, it doesn't seem like this is a rule. All it's saying is that you can take derivatives of polynomials, right, or different things put together that technically aren't polynomials, and you can do it term by term, right? So all you have to do to find f prime is to first find the derivative of 3x squared, which would be 6x, and then plus 8 is plus 0, right? And so your derivative here would just be 6x, okay? All right, so let's pause and remind ourselves what the heck this is. This is the derivative at x, at any x, is going to be equal to 6x. What does that mean? So at, let's say, x equals 2, the derivative would be equal to 6 times 2, which is 12. Well, what's that mean? That means that the slope of the tangent line to this function at 2 has a slope of 12. Well, think about that. That's a parabola shifted up 8, okay, and it's super steep. Looks something like that. And when I go out here to 2, at an x value of 2, there is a tangent line. That tangent line has a slope. Slope is another fancy word for rate of change. And so what we just said is the derivative at 2 is equal to 12, which tells you the instantaneous rate of change of that function at an x value of 2 is equal to 12. Okay, so that kind of pulls together everything we're doing. Hopefully. All right. Up at the top here, we've just got another function. Let's find these two values. So we're going to do term by term differentiation. You do your power rule. 4 times 2 is 8. X to 1 smaller minus 12. X to 1 smaller plus. There's a 1 here you can't see, and 1 times 2 is 2. And then I would say x to 1 smaller than 1, which would be 0, and then minus 0. Okay, I would not write this after this chapter, right? Because we know all this stuff, but this is just to show you term by term what's happening. So you end up with 8x cubed minus 12x plus 2. Okay, and if you want the function value at 2, the derivative at 2, all you do is plug in. It's nothing fancy. And so you get 8 times 8 or 64 minus 24 plus 2, which would be 42. Okay, and if you think about this is a polynomial degree 4. We know its end behavior is positive and positive. Usually looks like a W. And we know that if we go to an x value of 2, there is a tangent line there. It's positive, and it's very steep at that point. Okay, now we want the equation of a tangent line. This is huge, you guys. This is not gonna go away in calc. You're always looking for. That's great that you can find the derivative, but use that to tell me the equation of a tangent line at that point. So whenever you need an equation of a tangent line at a point, we did this before with the formal definition that was terrible. It's much easier now. You're going to use this form, which is a modified point slope form. Okay, it's going to be y equals your y value plus your slope times x minus your x value. Okay, you're always going to use this. This is just point slope form. Remember, point slope form a long time ago was y minus y1 equals m times x minus x1. All we do in calc is modify that a little bit and put this, add it to the other side so that it's solved for y. Okay, and so when you're asked to find an equation of a tangent line, you will always underline it, and you're looking for two things. You're looking for the derivative at that point, and you're looking for the actual coordinate point, 1 comma something. So you need a slope and a point. Okay, all right, well, we have f prime right up here. F prime of x is equal to that. And so f prime of 1 would be equal to 8 times 1 cubed minus 12 times 1 plus 2, which is 8 minus 12, or negative 4, plus 2 is negative 2. So we have that our slope is negative 2. And if I want a point, if I have an x value, this is a y value. It's a coordinate point x comma y. Y is not f prime or y prime. So you have to come back up to the original function and plug 1 in there. And f of 1 is equal to 2 minus 6 plus 2 minus 3, which is negative 4 plus 2 is negative 2 minus 3 more is negative 5. And this is all I need to answer the question about a tangent line. When you need a line, you need a slope and a point. You plug it into our form and you say the tangent line is equal to the y value, which is negative 5, plus the slope, but the slope is negative, so it's minus 2, times x minus the x value. You do not need to simplify that. You don't need to multiply it out. That's an acceptable tangent line in this class. always. If it's a multiple choice question and you have to distribute the 2 and stuff like that, then go for it. But this is where you can stop for me. Okay, let's do this one. So we've got a function here. It's a cubic. Find all the x coordinate where f of x has a horizontal tangent line. Definition. Horizontal tangent line tells you that the derivative is equal to 0. That's what that means. A horizontal tangent line is, think of a function, maybe this cubic, okay? A tangent line that's horizontal has a derivative value of 0. So this is just code to go find f prime, and that's easy. F prime of x is equal to 12x squared minus 24x, and set it equal to 0 and find those x values. So we can take out our 12x times x minus 2. That happens at an x value of 0 and an x value of 2. Let's just look at that graphically to verify what's happening here. So if we go in here and we type in our cubic, which was 4x cubed minus 12x squared plus 2. That's not what I'm trying to do. Sorry. 4x cubed, hit the over arrow, minus 12x squared plus 2. And if you zoom 6 this, the question said, look, find all x coordinates where the function has horizontal tangents. Okay. It looks like one of them's out of the range, so let's change our window here. Seems like we can go from -5 to 5, and then let's drop down more. Okay, get a better picture of our cubic. And where are the x values that cause horizontal tangents? Right there. At x equals 0, you can see the tangent line. And at x equals, what was the other one? 2. Okay, so when I hit trace and I go to 2, right there, the slope of the tangent line would be 0. Okay, f prime equals 0. All right, then it wants to know, well, where is f prime positive and where is it negative? Well, you guys have done this a lot, I think, in your past classes, right? You find these zeros, and then what I want you to do is just draw a number line for f prime with those zeros here. We know that f prime is equal to 0 right there, right? Right there, f prime equals 0. And right there, f prime equals 0. Those are the only places that it equals 0, okay? And so to find what's happening in these other areas, these other intervals, all you have to do is a test value. For instance, what happens at a test value of 1? Well, this is an f prime line. If you take 1 and you go plug it in here, you get 12 minus 24, okay? So it's going to be negative, and so it's less than 0 here. And if I plug in a test value of 5, I get 25 times 12 minus 24 times 5 is definitely going to be positive. Okay, and if I plug in -2, this is going to be a positive number, and then -2 times that makes that positive, so this will also be positive. And so this is very common. You're going to start the process by finding where f prime is equal to 0. That gives you your critical numbers that we'll define later. And then you can analyze your intervals around it and put these so that you can say f prime is positive, right? Where? Here and here. So how do I write that? From pre-calculus, hopefully you did interval notation. This is represented as -infinity all the way up to 0. And this guy starts at 2 and goes for forever. Where is f prime negative? Interval notation in between 0 and 2. Okay. And so what you're doing is you're practicing. You're finding where does f prime equal 0? Where is the slope of the tangent line 0? It happens at these x values. Okay, so I put those on my number line, and then I analyze around it. There's another way to do this besides a test value. Some of you might know that this is a parabola, right? Because it's squared, and it's positive, so it opens up. So the graph looks like this, right? And so you could see that f prime is going to be positive to the left. In here, it's going to be negative, and then after, it's going to be positive. Both ways are totally fine. Okay. All right. The derivative of the exponential function, you'll love this one. It's really easy. It's almost too easy. Some people freak out. Look, why is that? Y prime is exactly the same thing. The derivative of the exponential function e to the x is just e to the x. Okay. There's no tricks there. So here, f prime of x would be equal to the derivative of e to the x is e to the x. The 4 stays there. plus the derivative of that guy, you bring down the 3x to 1 smaller. Okay, so this is just to memorize. All right, let's see if we're done here. I think we might be. Yep, next one is 2.4.1. All right, so lots of stuff going on there. Just a quick summary. Okay, we learned that the derivative of a constant is 0, right? If you do not have a variable, the derivative is just 0 everywhere. If you do have a variable and it's a simple function, you can use what's called a power rule. We'll learn more rules when functions get more complicated than that. Okay, we learned that you can take derivatives piece by piece. And so you take the derivative of that term, and then you take the derivative of that term. Then we went back and we did some more work with tangent lines, right? In order to find an equation of a tangent line, you need a point and a slope. The slope is the derivative. That never changes. We're going to be doing tangent lines a lot. Okay, so you found your derivative, you plugged in your value to get the slope, and then you found your point that went along with the next value of 1, and you came up with your modified point-slope form. Okay. And then here we just practiced. We wanted to know where's f prime 0. We found those values. And then we wrote an f prime line, which you will always do. And when it asks these things about where is the derivative positive and where is it negative, you need to answer in terms of intervals. Okay. F prime is positive on these two intervals, from negative infinity up to 0, open, open, right? Because at 0, it's 0. And then again from 2 to infinity, and it's negative in between those values. Memorize that the derivative of e to the x is e to the x. You're good to go. Hopefully you're feeling better about all this, and we'll move on to the next one soon.